Hello everyone. Today we will solve Leetcode problem number 213, house robber 2. So what the question says, you are a professional robber planning to rob houses along the street. Each house has certain amount of money stashed. Again, similar to the house robber one, right? So each house has a certain amount of money stashed. All houses at this place are arranged in a circle. They have clearly mentioned all houses at this place are arranged in a circle. That means the first house is neighbor of the last one. Meanwhile, the first house will be the neighbor of the last one, right? So, meanwhile, adjacent houses have a security system connected and it will automatically contact the police if two adjacent houses were broken into the same night. So, given an integer array in nums, this one, so representing the amount of money of each house. Okay, so 232, the value they have given, that one, right? So return the maximum amount of money you can drop tonight without alerting the police. So we have to return the maximum amount of money we can drop tonight without alerting the police, right? So initially let's write the code and try to understand with the example 1. So here they have given nums 232. Output is 3. Why the output is 3? We cannot rob the house 1, money equals 2, and then rob house 3. Why we cannot rob the house 1 and then rob the house 3? Nothing but this one, 2 and 2, because they are adjacent houses, right? Circular they have given. Clearly here they have mentioned, right? So all the houses at this place are arranged in a circle. So the output will be 3. Let's write the code and try to understand clearly with the example 1. So initially what I'll do, if the array has less than 2 houses, here we have 3, but if the array has less than 2 houses, we will return the only house value, or we will return 0 if empty. So for that one, I'll just make use of the if condition. If length of the nums is less than 2, then I'll return nums of 0 or 0. First one. Second one, let's initialize the memo1 with the first house value, right? Let's initialize the memo with the first house value, nothing but in this case this one, right? So first house value for the scenario where we consider all houses except last one, this one. So this is simple. Let memo1 equals in the array nums of 0, nothing but the first element, right? First index, first element. So next, let's initialize the memo2 with 0. We are initializing the memo2 with 0 for the first house and the second house's value for the scenario where we consider all houses except the first one, except this one, first house. This one, we are considering all the houses, right? So we will initialize the memo2 with 0 and the first house, right? So how can we do that? I'll just come here. Let me come here, sorry. Let memo2 equals, let me give 0 comma first one. So it's till here, this is fine. Next, let's iterate through the houses from the second to second last house. From the second to second last house, right? In this example. So let's try. I'll just go with the for loop. For let I equals 1, then length of the nums and I plus plus. So this is where for each house we will be choosing the maximum between robbing the current house and adding the value from the 2 houses back. Nothing but when we say adding the value from the 2 houses back is nothing but I minus 2, right? Or not robbing the current house, nothing but I minus 1. So how can we write this? Memo1 of iterated value of memo1, right? Nothing but. So let me give this one correctly. Memo1 of I. Let's make use of the mat.max function. Here, nums of I less memo 1 of I minus 2. This is fair. Or we will consider 0. Finally, memo of I minus 1. This is fair. Sorry. Let me come here. Next, what we'll do, we'll iterate through the houses from the third to last houses. Last house for memo 2. This one was for memo 1. And next, we will iterate through the houses from the third to the last house. Nothing but, let me make use of the for loop again. Let I equals to length of the nums, and let's iterate this one. So similar to this one, right? Similarly, we will choose the maximum between the between robbing the current house and adding the value from 2 houses back. Nothing but I minus 2, or robbing the current house. Nothing but I minus 1. This one only I can copy, but let me type memo iterated value of the memo 2. Let's make use of math.max iterated value of the nums plus memo 2 I minus 2, comma, this will be memo 2 of I minus 1. This is fine. Next, finally, what we'll do, we'll return the maximum value between robbing, considering the first to second last houses. Nothing but memo 1 or the second to last houses. Nothing but memo 2. So this is simple. I'll just give return math.max of memo 1. Let's make use of the pop operation, as well as memo pop. So this is fair. So let me format the code and hit the submit. Let's wait for some time. So here the line number 8, this one, right? So here I have to mention memo 1. Sorry. Now this has to be good. What happened? Line number 15. Oh, this has to be memo 1. Let's submit again. So we are getting wrong answer, right? Let's check what. Here in the line number 7, this has to be, we are starting from the first one, right? We are starting from the first one, nothing but the second element. Nums.length minus 1. This has to be. Nothing but we are iterating through the houses from the second to the second last house, right? Second last house, when I say, it has to be nums.length minus 1. So this is fair. Now this works good, right? So let me, let's consider this example and try to understand clearly what we have written here. So in simple steps, what we have to do, we need to maximize the amount of money so we can drop from the houses arranged in a circle, basically arranged in a circle, right? So which means we cannot drop both first and the last house. So we cannot drop first and the last house, right here. So what are the steps to solve? First one is we will be splitting the problem. So first what we will do, there are either two cases. One is we can consider robbing houses from the first house to the second last house. Nothing but 2, 3 in our case. We are considering example 1, right? So what we can do, we can consider robbing houses from the first house to the second last house. Nothing but 2, 3 here, this one. Or we can consider robbing houses from the second house to the last house. Nothing but 3, 2 next to these two, this one, right? Either 2, 3 or 3, 2, right? These are the two cases. First one, what we'll do, case 1, we will initialize the memo with the first house value according to this one. Let memo equals nums of 0 we have taken, right? So we will initialize memo with the first house's value. First house value here we can clearly see the first house value is 2. Now the memo 1 is 2, right? So within the array, let's consider this one within the array. Now for the second house, we will compare robbing it or not. That is nothing but mat.max of 3 plus 0, 2. This one we are considering memo 1 for the memo 1, right? This step memo 1 mat.max of nums of I, this one. So this will be mat.max of 3 plus 0, 2, nothing but 3. So memo 1 becomes, we have already added 2. This was memo 1. Now we got 3 as well. We will compare this one. Mat.max of 3 plus 0, 2 is nothing but 3, 2. So max is 3. We will get 3. Nothing but we are adding 2, 3. Now the memo 1 is 2, 3, as we know. Next, what we will do? Now the memo 1 is 2, 3. So okay, let me delete this one and let me take only memo 1. This is nothing but 2, 3. So let's consider the second case, what we can do. So second case is 3, 2. We had seen for 2, 3. Now the second case is nothing but 3, 2. So for 3, 2, let's initialize the memo 2 with 0 according to this one. Where is memo 2? This one will be solving for this one, right? Initially we'll follow with the same step. So this one. Now let's initialize memo 2 with the 0. You can see here we are initializing memo 2 with 0 initially for the first house, and the value of the second house is nothing but memo 2 is 0, 3 according to this one. Nums of 1, 0, 3. So memo 2 now will be 0, 3, as we know. First we will initialize that one to 0, and the first house will be, we have initialized this one to nums 1, 0, nums 1. Nums 1 here we can clearly see that this is 3, right? Nums of 0, nums of 1, nums of 2. This one we can write 0, 3, right? So for the third house, what we can consider, we'll come to this step, memo 2 of I mat.max, this one, this step, and we'll compare with the numbers. So mat.max of 2 plus 0, 3 we will get according to this one, right? So this will be here in this step we will get 3, because 2 plus 0 is nothing but 2. 2, 3, max of 2, 3 will be 3 itself. So we are getting 3. So memo 2, now we have already 0, 3 and we have got 3. So total memo 2 will be 0, 3 initially we have got. Then again when we go to this step, we will get one more 3, right? Nothing but 0, 3, 3. So final decision is, what we can say, we can compare the maximum values. This step we will compare, we'll come to this step now, right? Let's consider this one. We will compare the maximum values from both the cases, nothing but memo1.pop, memo2.pop, nothing but 3, 3. So here also we got 3, max will be 3. Here also the max will be 3. So here memo1.pop and memo2.pop will be 3, 3. Max of 3, 3 is nothing but 3 itself, right? So according to the code, the max of 3, 3 will be 3 itself. So the output that we got is 3 here, you can clearly see, and the answer that we got is also 3. So the code works completely correct. So similarly you can check for the example 2 as well. So you will get the similar solution, right? So we can either rob the second house alone. We can rob either the second house alone or the second house in both the cases. Either we can do, and in both cases we are getting 3 itself. So in both cases, here also we will get 3, here also we will get 3. So we are getting 3 itself, which is the maximum amount we can rob without violating the circular house this one constraint. So we can either follow this one, or we can either go with this one, or we can either go with this one. In simple words, we can either rob the second house alone or the second house in both cases, and in both cases we are getting 3 itself. So the maximum amount we can rob without violating the circular house constraint in this case is 3. So this works correctly, right? So let me delete this one. So what will be the time complexity and the space complexity? Sorry, the time complexity would be big of n. Why the time complexity would be big of n? Because the function is iterating through the list of houses twice. Here you can see the function is iterating over the list of houses twice, right? So the total time complexity would be big O of n, where n is the number of houses. So let me give here time complexity would be big O of n. What would be the space complexity? The space complexity would be big O of n as well. Why? We are making use of the two arrays, right? We are making use of two arrays, nothing but here, this one you can clearly see. One is memo1 and another one is memo2 to store the maximum amounts wrapped up to each house. That will lead to the space complexity of big O of n. So the overall space complexity would be big O of n as well. Let me comment this one. Let me hit the submit again. This is just for my reference. So yeah, this works absolutely fine, right? So this is it. Thanks for watching, guys.